I am back with textbook page 69. We are looking at the rest of this review, and I'm on question number 5. How many ways can 5 different positions be filled by 9 applicants? So we need to decide if this is a permutation or a combination. And the definition of permutation is a selection in which order matters, and then a combination is a selection in which order does not matter. I'm going to give you just a little bit more info here. A combination is related to just choosing, selecting. A permutation is related to arrangement. So if your outcome is arranged in a certain way, you want to use the permutation formula. If you're just choosing items, then you can use the combination. So in this problem number 5, it is a permutation because the 5 different outcomes are arranged as people who got the job. There are 9 applicants. We're going to choose 5 of them, but they will be arranged in a certain way. They will be arranged as those who got the job. I'm not just picking people at random and saying I'm choosing this one and this one and this one. There is an arrangement to be considered. So the formula that we're going to use is the permutation formula. It has 3 variables, P, N, and K. And N is 9 in this case. There are 9 applicants, and there are 5 positions to be arranged. So the formula is, I have to look back. It's going to be N factorial over N minus K factorial. I will do this on the calculator as well. So N is 9 and K is 5. So this will be 9 factorial over 9 minus 5. That's 4 factorial. So this will be all clear. 9 shift 3 equals, it's huge. And then you're going to divide that by all clear. 4 shift 3 equals 24. And we will have 362,880 divided by 24. And that is 15,120. Again, that's the p-value here, 15,120. So you could have that 15,120 different arrangements of those 5 people. And I like answer D on this one. But let's put this through the calculator just to make sure that you know how to do it that way as well. Those of you planning to go on to college, I would recommend knowing both ways because I think a knowledge of that formula will help you in college. Okay, so the first thing we want to do is clear the calculator. So that's all clear. Then we will put in the N value. We shift, and this is permutation, so we want to shift 1, and then put in the K value and the equals. All clear, 9, shift 1, 5 equals, and there's that number again, 15,120. Alrighty, number 6. I will need a new piece of paper. Which number represents the number of ways to choose 5 people from a group of 15 people for a task force? Okay, so again, we have to figure out, is this a permutation or is this a combination? And the key word here is choose. If you are just choosing, that is combination. The key word is choose. So we're looking for, it's either C or D. We just need to get the values of N and K. I know we don't have to solve this one, but I think I'm going to, just because it's good practice. But we really just need the values of N and K to answer it. So N is the number that we're choosing from, and that's a group of 15. And K is the number we're actually choosing, and so that is 5. I could close my eyes and do this choosing. It's not based on an arrangement. It's simply choosing from a group. So the formula, remember, looks like this. You would find the permutations of N minus K. Of NK. And then you would put that all over K factorial. So combination of 15, 5. And that's the answer we're looking for right there. We don't have to solve this one, even though I'm going to. It's going to be answer C? No. Yes, C. Excuse me. Okay, so let's go ahead and solve it. So we have the permutation of N, 5, all over 5 factorial. So the combinations will be all clear, 15 shift 1, 5 equals 360, 360, and then 5 factorial is shift 3, that's 120. So the combinations would be 360, 360 divided by 120, and that is 3003. But the answer for us is right here. If you wanted to do this using your calculator, you can. If you need to solve it, sorry, I didn't mean to do that. And you know what? I think I'm going to take a picture of this calculator setup, and I won't have to keep doing this. This is about as exciting as watching grass grow. Okay, let me take a picture right here. And then if I need it again, I'll have it. So we're going to put in all clear, the N value, shift, and this is the combination function, so that's 2. Then the K value and equals. All clear, 15 shift 2, 5 equals 3003. So that just confirms that my formula was correct, but again, the answer we want is C for this one. I think I'm going to highlight my answers in blue because I do need to come back and check these. I have been known to get combinations and permutations mixed up. If I don't really stop and think about this, I use the wrong formula sometimes. So these are not my favorite problems. All right, on this page we have skill practice down there at the bottom. And we need to come in here and take a look at those 3 problems, or excuse me, 5 problems. Number 1. Hillary packs her lunch with 3 small dishes. 1 pasta, 1 fruit, and 1 vegetable. She can choose from 2 different pasta dishes, 2 different fruit dishes, and 2 different vegetable dishes. Complete this tree diagram, then find how many lunch combinations Hillary can make. Okay, this is not the way I would do this problem. I'll show you that in just a minute. But since they want us to do this problem, we need to follow their instructions. So she could choose pasta 1 or pasta 2. That's her first choice. Then once she makes the pasta selection, she can choose vegetable 1 or vegetable 2. If she chose pasta 2, she could also choose vegetable 1 or vegetable 2. And then once she's chosen the pasta and the vegetable, she still needs to choose the fruit. This brings back horrible memories. I hated drawing these things. Although they make sense to me, I just didn't want to do it. And I'll stop complaining now, because I made a mistake up there. Did you catch it? This should be fruit 2. And then we have to do it one more time for these. Just going to go ahead and draw my lines in. And fruit 1 and fruit 2. Fruit 1 and fruit 2. Now, with the tree diagram, I'm not even sure I told you this. The way to know all of the options is to count the last row of branches. So there's 1, 2, 3, 4, 5, 6, 7, 8. So Hillary has 8 choices using those criteria. She chooses a pasta, and then a vegetable, and then a fruit. She could do it in an opposite order. She could choose the fruit first, and then the vegetable, and then the pasta. She could choose the vegetable first. It doesn't matter. You will still get 8 choices. Now, I want to remind you of something. And bear with me. Let me go back to the one I want. I turned right to it. Let me flip back in my notebook here to page 64. Remember that thing we called the, please tell me I wrote it down. 64, the core skill. I know we did it because I remember doing it. I didn't write it down, so let me give you the name. Okay. Did I do the core skill on page? Yes, I did. It's the problem about the yogurt and the fruit and the syrup, but I did not write down the name of the counting principle. I'm sorry, I should have. So if you want to go back in your notes to this page, it's on page 64, right before we talked about permutations. The core skill is using a very important math rule called the fundamental counting principle. And I made a serious error by not writing this down. I must have been doing that one in the middle of the night. The fundamental counting principle, and this is principle with an LE, not principal like at a school. Fundamental counting principle says that you can multiply to find combinations. And I'm going to go back to that one that we just worked, and I'll show you. I think I'm going to even bring this over here. So anywhere you can use a tree diagram, you can use the fundamental counting principle. So let me go back to that example that I just did right here. And let's apply this fundamental counting principle to this problem. So remember that she's going to have pasta and a vegetable. I am hungry, and this sounds so good to me. And a fruit. So how many choices does she have for pasta? She has 2. How many choices does she have for vegetables? 2. How many choices for fruit? 2. So 2 times 2 times 2 is, we already know what it is because we've already done this with a tree diagram. But if you don't like drawing the tree diagrams, or if the diagrams get too complicated for us to be able to do, you can use the fundamental counting principle to do that. That one was one that I loved because I hated drawing the diagrams. Okay, number 2. There are 12 people who are trying to get 3 spots on a school council. Andrew calculates that there are 1,320 different outcomes. Is Andrew correct? Explain. So we have to decide if this is permutation or outcomes. If it's permutation, let me just do it this way. Oh no, I deleted my calculator buttons. Go back up here. Hold on 1 second. Copy that. Bring it down here. There we go. If it's a permutation, let's see what we get, because this is going to help us explain it. So on this one, I'm going to do the permutation formula. And I'll tell you what, let me just copy that for the next set. Okay, so permutation of 12, that's the number of people who are trying to get 3 spots on the school council. So permutation is going to be all clear. The n value, shift, this is a permutation, so it's number 1. The k value is 3, and that is 1320. That's what Andrew got. Okay, let's look at what we get when we do the combinations. Because remember, the combination will remove redundancies. So any value that's duplicated gets removed. So we're going to do the same n and k. Nothing changes there. The change is going to happen after shift. We want the second function there, which is the combination formula. So all clear. 12 shift 2, 3 equals 220. So once the redundancies are removed, where order didn't matter, it doesn't matter who finished first or second. It's not a race. Every position is equal. We're just trying to choose the 3 people who fit into that category. So I'm going to say that Andrew is wrong. Andrew did permutation. He should have done combination. because order doesn't matter here. It doesn't matter if you get the first seat or the third seat, as long as you get a seat. Okay? So it's not like filling a job position where you are qualified for a certain role, like we had up here in this one. Was that the one? Which one? No, number 5, excuse me. In this one, where we had applicants for a job, their qualifications matter as to which position they get. So the order does matter as to how you would fill the positions. But in this situation, the seats are all of equal weight. It's just a matter of picking 3 people, choosing 3 people to fill the seats. So I'm going to say, this is not multiple choice, I'm going to say that Andrew is wrong. He is incorrect on that one. Okay, number 3. Oh, I'm out of paper. Let me put some more in. And I think I'm just going to go ahead and make 2 more just in case. So let me clear this page and then duplicate that page. These digital notebooks are wonderful if you like keeping your notes on the computer. They really are. Okay, number 3. I'm on page 69. Anthony is packing clothes for a trip. He packs 4 shirts, 3 pairs of pants, and 2 pairs of shoes. He can wear any shirt with any pair of pants and with any pair of shoes. How many different combinations of outfits has Anthony packed? Explain your answer. Well, I'm going to do it the nightmare way, and then I'm going to do it the easy way or easier way. So first, I'm going to list all the shirts. So I'm going to list shirt 1, shirt 2, and you may have guessed what I'm building here, shirt 3, and shirt 4. And I'm just using those little subscripts to designate the different shirts. So he has 4 choices of shirts. And then he has 3 choices of pants. And I'm just going to do this once and copy it. So there's 1 pair of pants, pants 2, and pants 3. So he could do any of those pants with that shirt. He could do any of those pants with this shirt. He could do any of the pants with shirt 3. Or he could do any of the pants with shirt 4. Now, at this stage of the game, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 choices. But we are not finished. And I am not going to be able to finish until I make some more room. So here comes the option for shoes. And he only brought 2 pairs of shoes. Bless his heart. Can you imagine if he brought 5 pairs of shoes, how complicated this would get? Okay, so he could put this combination together right here. He could say, I'm going to wear shirt 1, pants 1, shoes 1. Or shirt 1, pants 1, shoes 2. Or he could do these combinations. And you see how very complicated this is getting. It's easier for me because I'm drawing and copying and pasting. But if you're having to draw this all at one time, I don't even have enough room here to get all this in. I'm going to make room because I want to show you this, and then I'm not doing this again. So let's bring down the tree just a little bit to make room for all of the branches. I've literally done these where they have hundreds of branches. It was insane. I hated that class. As much as I love math, I still hated that class. Okay, so there's that one. What I'm trying to get us to is the ability to count those branches, because that is going to confirm what we are going to find with the counting principle. I used to use this example when students would ask me, why do I have to learn all these math rules? I hate math rules. And I understand that. I truly do. There are lots of rules in math. But here's a real good answer to that question. So I'm going to count the branches on this last row. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So Anthony, has 24 choices of outfits. And I would make the argument that this is a small suitcase. When you think about what's actually in the suitcase, there are 1, 2, 3, 4 shirts, 3 pairs of pants, that's 7 items, and then 2 pairs of shoes. So he only put 9 items, if you count the shoes as one item, in the suitcase. But yet he has 24 choices of outfits. So if I can draw a tree diagram, I can use my best friend, fundamental counting principle. So let's see how that works out for us. So it says to multiply to find your combinations. So he has shirts, 4 choices, and pants. That word "and" is important. Pants, he has 3 choices. And shoes, he has 2 choices. The word "and" means multiply, and you'll see that again in the next lesson when we talk about probability. So we have 4 times 3 is 12, and 12 times 2 is, guess what? 24 choices. So if I know about the fundamental counting principle, I don't have to draw that tree. I can just use that counting principle to find the answer I need. But there's the tree if you'd like to print this page. And I'm not drawing any more trees unless they tell me to. And then I'll do what they say. All right, so the answer here is 24 combinations. Number 4. You see why I needed another sheet of paper. Keisha has 14 songs in a playlist. Keisha wants to know how many different ways she can play the songs in her playlist. What are 2 different ways to show this? Well, one of the ways is to simply do a factorial. How many songs does Keisha have? She has 14. And she is going to do a playlist. So that's an arrangement. That's going to be a permutation if we did it with a formula. But let's do it with a factorial and see what we come up with. So 14 factorial, when you put that in your calculator, you get this, if you're using the Casio. Let me double check this. 8.71782912 to the 10th power. So what this means is that the calculator can't handle a number that big. It cannot display a number that big. So it gives you scientific notation. So one way to show this value is to simply write 14 factorial. The other way is to show, you really could show it three ways. You could show it this way. That's the second way. But then let's put this in standard notation, and that will be yet a third way that we could show it. I wanted to show you this so that you would understand what's happening with your calculator. And the key to this whole thing is sitting right here. See that 10th power? That means that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces in our standard answer. And we know, we learned this back in first or second grade, that every 3 spaces gets a comma. And then we learned in middle school what the names of those spaces are. This is the units. I guess we learned before middle school. This is going to be the thousands period. This is going to be the millions period. And this is going to be the billions period. Okay, so we learned the names of those place values. All right, let's write this answer into these blanks. Now, we've already dealt with this. That just tells you the number of spaces in standard notation. So there are 10 spaces. We're going to start over here at the left and start dropping those numbers into the blanks in order. And then I run out of numbers. I did 8, 7, 1, 7, 8, 2, 9, 1, 2. So I have to put something in this last space, and it will be a 0. So this is the number in standard form. Factorials very often give you these enormous numbers. And if you wanted to go ahead and put yet another form, we could use word form. And that would say 8 billion, comma, 717 million, comma, 829,000, comma, 120. I thought this was going to be a fairly easy problem. And it is, I guess, depending on how well you know your place value. So I've given you 4 ways to write this answer. You can write it as 14 factorial. You can write it in scientific notation. You can write it in standard notation. Whoa, That didn't work, did it? Or you can write it in word form. All of those mean the same thing. And I have no idea what the answer key writes. We'll have to check it when we get there. Those are just some ways that I can think of to do it. Let me see if I can think of one more way. I'm not sure this will work, so let me... Yes, there is one more way. I think I said it back at the beginning. I didn't mean to. But this is a permutation because order matters. If you're doing a playlist, it depends on... The playlist is going to play songs in a certain order. That's what a playlist does. You put your favorite song as the first one, your least favorite song as the last one, or however you want to arrange it. So you can do a permutation here. You can say that there are 14 songs. She's going to choose 14, and the order matters. So it would be, I've forgotten my formula yet again. N factorial over the difference factorial. You'd think by now I would know that. So we're going to have 14 factorial over n minus k factorial. That is going to be 14 minus 14 is 0 factorial. So we'll have 14 factorial on top, which is what we just did. To the 10th power. And then on the bottom, we're going to have 0 factorial is 1. And so that will equal what we got up there in that first example. So if you don't catch that it's a factorial and you just do it as a permutation, it'll be fine. You'll still get the same answer. Either way is fine. So that's yet another way that we could express that value. Number 5. There is another formula for combinations. Explain how it is like the formula in the lesson. Oh my gracious. Okay, here is the new formula that they've given to us. I would not lose sleep over this problem. This is a theory question. But let's go ahead and do it.